Hi, I'm Larry Puckett, the DCC guy. Well, as the title says, today we're going to talk about command stations and boosters, what they are, how they work, and what you use them for. So let's go ahead and get started with the video. So let's go ahead and take a look at command stations and boosters. And I'm going to focus primarily on a couple of the very popular brands here. Not that I don't have some others, but basically a command station is a command station in its basic form. Some of them have much more features than others, and we'll talk a little bit about that. But I don't need to show you every possible command station and booster in my collection to get the point across. Okay, let's go ahead and get started with our look at command stations and boosters today. But first, let me point out that this series on DCC basics is going to be something that will be interspersed amongst the various other videos that I do. So I don't want to get you guys bored with just looking at one component after another. We'll be doing some other things, so this will be, something that I will slide in every other video or every couple of videos, something like that, so that we can cover the full gamut of DCC components over, say, the next year. So first then, let's define what we're talking about. What is a command station? Command stations like this NCE Power Cab and this top-of-the-line Digitrex DCS240 are basically small computers. They're microprocessor based, and their primary function is to take commands from you via a throttle or whatever source that you provide, and convert those into commands that can be sent out to your decoders and your locomotives and other pieces of equipment such as accessory decoders. And then those commands can be acted upon by the locomotive to turn on the lights, to turn on the sound, to do all kinds of other things, to control the speed, the direction of the locomotive, to throw switches. All of those kinds of things are created within the command station, be it, like I said, the Power Cab or the Digitrex DCS240. Now, something like the Power Cab, it has the command station built right into the throttle. So that means that every time you push a button here, a digital signal is sent to the microprocessor inside of the device, and then it converts it to some sort of digital command that can be sent out. Now, the thing about that is, those digital signals that are created by the microprocessor are very low voltage, very low amperage. And then something has to be done in order to get that signal up to the desired voltage and amperage that you want on your track. And that's where the booster comes in. And we'll talk about the booster in just a minute. Now, as I said, these are basically computers, small microcomputers with a microprocessor inside of them that does all the work and all the computing. And just like other computers, like your Macintosh or your Windows computer, your cell phone or an iPad, something like that, when you get it, there's lots of settings that you have to set up. And the same goes for your DCC command station. With something like the Digitrex system, there's a lot more settings that you can adjust in here. And they control things like how fast the unit will shut down, if there's a short circuit on the layout somewhere, and various other features. So those are called, in Digitrex parlance, those are called op settings or op switch settings, and various other systems have their own. And you'll have to go into your manual and figure out which settings you want to set up to customize the operation of your command station to go with your model railroad and what you want it to do. Now, there's a lot fewer things that you can do with something like the Power Cab. And there's a lot of other features that are just not available on something like an introductory system compared to a top-of-the-line command station and booster system. Now, as I said a minute ago, when a DCC signal is created inside of the command station, it's low voltage and low amperage, and it has to be boosted to the track voltage and amperage that you desire. Now, one thing that's important to understand is that all of the DCC command stations that I'm familiar with now come with a booster built in. So no matter whether you're talking about the power cab that has a booster built in to the handset along with the command station microprocessor, even the DCS 240 shown here from Digitrax has a booster built in as well. So when you initially buy a system like this, you're going to get a command station and a booster. And I have a friend who has a much larger layout than mine, and we operate it entirely using a single DCS 240 rated at 8 amps. So you can get a lot done with a simple 8 amp single system like the DCS 240. Now, when you need more power, that's when you go to a separate booster. And the Digitrax boosters look essentially just like this DCS 240, the white box with all of the controls up front, that kind of thing. But all it provides is the booster, the ability to take the DCC signal and boost it up to the desired track voltage and amperage that you want to go out to the track. And the same is true for NCE systems and any of the others out there. All the other systems that I am familiar with do offer a command station with a booster built in, as well as additional boosters if you need to expand the amount of power available to your layout as your layout expands. Now, the great thing about the power cab is you can buy this SB5 Smart Booster and increase the amperage available to your model railroad by just plugging that in, and then your handset just becomes a throttle. With the power cab, the output voltage that goes to the track and the amperage is controlled by this little power supply that came with my unit. They have a slightly different one, I believe, now that comes with these, but this one is rated at 13.8 volts and 1.44 amps. So that's what you're going to get, something close to that, going to the track when you run this through the power cab. So the power cab is basically a throughput type of device. Whatever comes in is going to go through, and approximately that voltage and amperage is what you're going to see at the track. Now, that's also true for their Smart Booster, and this is their Smart Booster. Now remember that with the power cab, both the command station and the booster are built into this handheld throttle. So everything happens right here. Now, if you need more than the 1.4 amps or 1.44 amps that this can put out, you have the option of going to the NCE SB5 Smart Booster. So this is sort of a upgrade command station and booster combination that works with the power cab. And I did a video on how to install this on your layout, and I'll put a link to that above me here. But at any rate, this is rated at 5 amps. And as I'll show you here, it also is a throughput type system in that this power supply that comes with it is selectable for either 12 volts or 13.8 volts. And that's what you'll see at the track. It's also a 5 amp rated power supply. And that gets passed through the booster and goes to your track. So you can get either 12 or 13.8 volts at 5 amps. So you can go up from 1.4 in this case with my power cab to 5 amps. Not bad. But that's the limit with the power cab. It doesn't have as many features as with some of the other bigger systems, which have built-in ways of allowing you to adjust the voltage going out to the track. On the larger NCE systems, they have a little trim pot inside, a little potentiometer that you can use to tweak the voltage itself. Now, let's take a look though at the Digitrax system. Hit that little red subscribe button, and when the little bell comes up, click on it and click all. Now the Digitrax system here, this is the DCS 240, and you can see here that it has a setting for different voltages. Let me come in a little bit closer. So if you look right here, we've got a little switch, and that controls the scale setting. And you can have either OG, N, or HO, and that represents different voltages at the track. So you have an option of N scale, which is somewhere around 12 volts, HO scale, which I believe is around 14 and a half volts, or OG scale, which would give you something, I believe, around 18 volts. And if we look over here, you can see that the input side, this particular unit can be supplied either 5 amps or 8 amps. So you have the option, depending on which power supply you purchase, of inputting 5 amps or 8 amps. And that's what you'll get out at the track. Now, another neat feature of the Digitrack system is you have a way, using your throttle, to tweak the voltage. So you can make finer adjustments of the voltage that is set by this little switch here. And it's a little 3-position switch that allows you to set that. And that allows you to tweak the voltage to exactly what you want. And you can selectively get either 5 or 8 amps out. Now, there are boosters which look just like this and have many of these same type of features. They allow you to input, I believe, 3, 5, or 8 amps. So you got a much broader range. They even have one that has a dual output function. So you can have either a single booster built into a box or 2 boosters built into a box if you need that much power. Okay, and then this little plug-in terminal here allows you to make all sorts of connections to your main track feeds, your programming track feeds, and things of that nature, the power input feeds. All of that is provided right here. Another neat feature, they have a USB connection built in right here. So you can plug this in directly to the USB port on a computer, and you're ready to run JMRI Decoder Pro. And it's built right in. With the NCE Power Cab, you have to purchase a separate USB interface that will allow you to make that connection. Then over here they have 3 different sockets for connecting a throttle or a throttle network or various other, what they call their LocoNet. And their LocoNet is sort of like an Ethernet type of network that allows you to connect all your throttles together and to communicate with some of their smart devices. Over here they have a mode switch, run, op, and sleep. So you can flip it down and put the system to sleep. You can put it into op mode, or you can put it into run mode. Now, op mode is what you use when you're making adjustments to those op switch settings that I was talking about earlier. So that's one way of doing that. Another way is, once you've got this connected to JMRI and Decoder Pro, there are function capabilities built in there that allow you to use Decoder Pro to change the preferences or op switch settings within your Digitrack's command station. Now, as I said, this is the top of the line system. They have the DB210 Plus, which has a little bit smaller feature set, less memory, that kind of thing. It does now have its own USB port built in. Digitrax is providing a USB port on most of their boosters and command stations now, simply because it makes it easy for you to upgrade the firmware in your system, as well as connect everything into JMRI, Decoder Pro, or whatever program you want to use on your computer and use with your DCC system. So that's some really nice features. And like I said, this is their top of the line unit, and their DB210 Plus is their next smaller unit. So you can take a look at those. They mainly, as I say, differ in the number of features that they have and the amount of memory they have for storing locomotive addresses, things of that nature. Now, I don't have one of the newer Digitrax boosters. I really don't need it. I can use one of my older Digitrax DCS 200 command stations as a booster as well. So I really haven't purchased one of the newer ones, but they look pretty much the same, have essentially the same type of feature set as you would expect on any other booster. So why would you want to be able to control something like the amount of time that it takes for a booster to shut down after a short circuit occurs on the model railroad? Well, let's say you use frog juicers on your layout. You want to make sure that the frog juicer always has plenty of time to correct a short at the frog before your booster reacts and shuts off power to the layout. And the way that you do that is you increase the delay, the amount of time that the booster waits before it shuts down. So that's one of the things you can do. And actually, I had a real problem like that, because when I first started using frog juicers on the layout, I ran into that problem. because sometimes the frog juicer would have time to react and correct the short circuit at the frog. Sometimes it wouldn't, and the booster would go ahead and shut down, or the command station in this case. And what I ended up having to do was slow down the reaction of the booster and allow enough time for the frog juicer to do its job so that the booster built into my Digitrex unit would not shut down. And basically, the only thing that I did was increase the delay to ½ second. So that was very easy. It's one of those settings that you can change in the Digitrex up switch settings that allows the frog juicer to have time to work. And this also comes into play with PSX as well. Well, that's a wrap for today's video. So now hopefully you know everything I know just about command stations and boosters, the differences between them, how they work, what they do, what you use them for, and in an upcoming video, we'll talk about how you connect them up and connect them to your layout. So keep coming back for more videos in this series on the basics of DCC. In the meantime, have a great weekend, have a great week, and I'll see you here next week with another video from the DCC Guide. Bye now.